Hi everyone. Today we're going to talk about the concept of probability. The probability is a study of uncertainty. This is of something happening, is the likelihood or chance of it happening. So, first we're going to talk about the basic concept and the definitions. An experiment is a process that, when performed, results in exactly one of two or more expected results. So the expected results we called outcomes, and all the possible outcomes we said sample space, and it is denoted by the letter S. An event is one or more of the experiment's outcomes. So event means the outcomes in the experiment we called event. And always the values of probability lie between 0 and 1, where 0 represents an absolute impossibility. The event will not happen. And 1 represents absolute certainty, definitely happened. For that, we have the value 1. So always the value is lie between 0 and 1. See, for example, in the case of a die, the event of getting a face of 7 has a probability of 0. Because for die we have only 6 faces. 1, 2, 3, 4, 5, 6. So 7 not possible to get. So for that case, the probability of the event is 0. The event of getting a face of anyone, 1 or 2 or 3 or 4 or 5 or 6, has a probability of 1. So for definite event, absolute certainty, we will obtain the value of probability is 1. Next, we're going to talk about the basic concept of the probability with some examples like tossing a coin. When you're tossing a coin, we have two outcomes, head and tail. Head we denote with H, the letter, and tail we denote with T. And tossing a coin twice, so what about the outcomes? So for getting outcomes, we can use the tree diagram. Let me explain the tree diagram for tossing a coin twice. So first, tossing a coin, we have H and T. So for the second time, we need to extend the branch. This is called branch for the tree diagram. So for each case, we will obtain H and T. So what about the outcomes? HH, HT, TH, and TT, right? HH, H to H, HH. This is given in the picture, HH. Then HT, TH, and TT. In the same way, we can draw for 3 times tossing a coin. Again, you have to extend the branches H. So for each and every outcome, we have to extend 2 branches. Because here we have only 2 outcomes. Possible outcomes are head and tail. So we need to extend by 2 branches for each event. Like this. So this is for tossing a coin 3 times. So now the outcomes are head, 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 tail. You can follow the arrows. Head, tail, head, head, tail, tail. Then you can start with tail. Tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are the possible outcomes, and for find out outcomes of the experiment we can use the diagram. This is called tree diagram. Next, for rolling a die. So for die we have 6 faces, 1, 2, 3, 4, 5, 6. Rolling a die twice, so we have given in a picture representation, and this one also we can use the tree diagram. So first times 1, the possible outcomes 2, 3, 4, 5, 6. So totally 6 outcomes. So this is rolling a die. For the second time, so you have to extend the branches here. Total possible outcomes are 6. So I need to extend for each and every case 6. So you can start 1, 2, 3, 4, 5, 6. And in the same way for 2 also we have to extend 1, 2, 3, 4, 5 and 6. Same like for 3. 1, 2, 3, 4, 5, 6. And similarly for 4, 5, 6. So what about the outcomes? You can start from 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So this is given in the picture. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And you start with 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Same like 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And same like 4, 5, 6. So total outcomes here we have 36. So this is a tree diagram for rolling a die twice. Next we talk about a standard deck of cards. So standard means here we don't need to consider jokers. So there are 4 types: spade, clubs, hearts, diamonds. Totally 4, and 2 are in black color, and another 2 are in red color. So we have the number here. The number cards start from 2 to 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the another 4 cards we call special card. J represent Jack, Q that represent Q, K King, A is a special card we sometimes we call as. And this, I know the symbol of for leaf symbol, so you have to remember spade. Then clubs, same like the same number card and the special card. So for one type we have 13 number of cards. 13 cards we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And totally we have 4 types. So 3 times 4 gives 52. So total number of cards we have 52. So second card, clubs, the name is, and it looks like a flower. And hearts, that is in heart shape in red color. And diamond is in the shape of diamond. Okay, remember for standard deck we don't have jokers, right? So here we're going to talk about the coin, dice, and standard deck of cards. So we have a question according to the concept. This is the basic level, so we have only these things. And tree diagram, already I explained the tree diagram for tossing a coin twice. Tossing a coin twice. Let me explain again. So when you tossing a coin, so we have a head and tail. Then we need to extend the branches for each event. So it gives you the outcomes, sample space, or we can say sample space, or h comma h, ht, th, tt. You can use any bracket for this, or if you want you can use normal bracket like open bracket. You can use this for sample space. Fine, no problem. Okay, and similarly for tossing a coin 3 times. So these are the sample space. So already I explained. So we need to extend the branches again for each event. So HH, HHT, HTH, HTT, THH, THT, TTH, and TTT. Okay, let me talk about the example 1. Show the sample space for tossing one coin and rolling one die using the tree diagram. So we need to show the sample space for tossing one coin, rolling one die. So first you need to think about tossing one coin. What are the sample space? H and T, the sample space for coin. For rolling die, what are the sample space? 1, 2, 3, 4, 5, and 6. So 6 outcomes we have. So now we have to combine the both. So first you can take the coin H and you have to extend the branches in 6 number of branches because we are combining the coin and die. So it should be like this. And the second one for T also we have to do the same. So the sample outcomes are H1, H2, H3, H4, H5, H6. Same like T1, T2, T3, T4, T5, and T6. So these are all outcomes, or we can say sample space. That's it for the question. Next we talk about how to find the value of the probability. The probability can be defined as number of favorable outcomes divided by total number of possible outcomes. So the number here we concentrate how many number of outcomes. And first in the numerator we have to consider favorable outcomes, divided by the denominator we should consider total outcomes, okay, for each and every experiment. Okay, the question number 2, when a fair coin is flipped, what is the probability of the coin coming up heads? So we have a sample space for for a coin, tossing a coin or flipped a coin, head and tail. So how many number of outcomes, total number of outcomes? So we should keep the total number of possible outcomes 1, 2. So you have to write that number, total number of outcomes on the denominator. The numerator, what I'm looking, okay, favorable. So what is the probability? The question, what is the probability of the coin coming up heads? So head, I have only one head. So 1 divided by 2. 1 divided by 2 is the value of the probability. That's it. And thank you. And the rest of the topic you can watch part 2.